So to start an Infraworks model, it helps to have a GIS file set up already with all your layers organized together. The reason I recommend doing this is because you can easily check the coordinate system and kind of know what these shapefiles are associated with. So right now the coordinate system for this model, and I have information for the city of Sedona, Arizona. It's set to State Plane, Arizona, Central, FIPS, feet. So if you're following along and you're bringing your data into your ArcMap document, make sure that this is your coordinate system. So the way to start a model is to set up a bounding box extents. What I'm going to do first actually is I'm going to bring in the aerial photography so I kind of know what I'm looking at. So I'm just quickly going to go to where I saved my information, which is here. I'm bring in all these aerial photos. Okay, so I'm going to bring in the aerial photography. So we're going to build a model of this area right here. I'll drag this down. Of this area right over here. I want to get some of the mountainous areas because that's the fun part of this whole exercise. So it's maybe an area like this. So what I'm going to do is I'm going to draw a rectangle using the drawing tool of the area that I want to build a model for, like so. And then I'm going to convert that rectangle into a shapefile. So I click on, with this rectangle selected, I go to convert graphics to features. I'm going to call this one, let me save it into my Arizona folder. I'll call this one Sedona B box for bounding box. Save it as a shapefile, click save, click OK. So do you want to add to a layer, to map as a layer, click yes. So now you have a bounding box. So with this all set up, I have my building footprints, I have my aerial photography, I have my DEM imagery. And actually this is a bit of an issue. You see the DEM, in my case, does not completely overlap with the bounding box. So actually what I'm going to do is I'm going to take this box, and this is just my mistake. I'm just going to change it. I'm just going to move it over slightly so that it fits within that area using the editing functionality in GIS. Okay, so with that set up, the bounding box is good. Let's go to Infraworks. So in Infraworks, this is the opening screen that you should get after you sign in. You need an Autodesk account in order for this to work. Since you guys are students, you should be able to easily sign up using a student account in Autodesk. To start a new model, and it's the reason I can't see it is because it's squished here. But right here, there should be a create new model button. That's because it's squished on my computer. You can't see the whole label. So click on this. This is the overall settings of your model. So we're going to just give it a name first. We're going to call this one Sedona. It's going to ask for a location for this model. Since you guys probably don't have Autodesk 360 accounts, you would want to store on your computer, which is this second option here. And it's going to automatically set a folder within your documents of your computer for your Autodesk Infraworks models. Then with that set up, you want to go to this model extent tab. You want to check this box, define model extent. Then you want to click this button called load extent from file. So this is where you bring in that bounding box you just made. So I'm going to bring it in right here. It's Sedona B box. So just find that shapefile wherever you saved it. Click open. It's going to ask you how do you want this shapefile to be read. Either use the first polygon or use the data extents. I recommend using the data extents. If you use first polygon, it's going to trim the model to the actual polygon itself. Data extents is essentially setting a bounding box around the polygon. Bless you. So I choose data extents. It's all set, so I click OK. Okay, so when it's done, what you get is basically a box. Now this box here, is the same exact box as the bounding box you see right here. So this is what I mean by setting a location. If you zoom out, of this area, you'll see that it's located in the correct location on the planet. In this case, Arizona. It's right over here, so this is right. So I'm going to zoom back in. This little rectangular plane is set to 0 elevation right now. So we want to actually give it some topography. So the way to do that is you click on this little orange button at the left corner of your frame here. And you click on this second button here, which is the Create and Manage Your Model button. And then here, this is kind of the tools set that you use to actually build and add data to your Infraworks model. So what you want to click on is this first button here called Data Sources. This brings up this Data Sources column on the side. And you can actually just, let me see if I can try to, oh, for some reason, trying to, I guess it's not working. You should be able to like link it to the side, but for some reason it's not doing it. I don't know why. Anyway, that doesn't matter. So the way you bring in data sets is to use this button right here, this Add File Data Source, and you want to click on this drop-down arrow, and these are all the data types that you can bring into Infraworks. So the ones that really matter to you guys is this first one, 3D model. This is how you bring in your things from SketchUp or Rhino or Revit. Raster, this is how you bring in your topography, your DEMs, your ortho images, and then SHP, this is your shape files. So let's start with Raster. Raster, because we want to bring in topographical information, because DEMs are rasters. So click Raster, and then go to, I'm going to go to my desktop, go to the box, gate, and then go to this little line here, the N35W112. This is the DEM that I downloaded from USGS. And then click on this folder here. And then if you don't know what the DEM is, it usually is the largest file. So all these files here, the name is incorrect, but usually the largest file is the DEM. So click on the one, the biggest file size, and click Open. Now this hasn't done anything yet. What you want to do is you want to double click on the item that just popped in. So double click on that. And it brings up the data source configuration. So usually what you do is in this line right here where it says type, it would ask you what kind of information this is. In this case, it knows that's a DEM and it knows that it's terrain, so you actually don't have to do anything here. And also what's nice about this image is that it brings in the correct coordinate system already. So you actually don't have to change this line here. For some pieces of data, you need to go to this drop-down, click on this little globe here and pick the actual coordinate system for the site that you're working with. But for this case, in this case, it should come in the correct location, which is LL83, which I've lost, so I'll find it again, LL83, which is this one right here. So I basically have done nothing. So just click on this button, close and refresh. You always want to click close and refresh. OK doesn't do anything. Close and refresh is the button you want to click on. Close and refresh. It's going to start thinking about it. And refreshing. Refreshing means it's making the model. It's like making it real. So just give it a second. OK, then after a couple seconds, you've basically built a terrain of Sedona. As you can see, it has all the cool geographic features on the site, such as these mountains, all this fun stuff here. And again, as I mentioned, if you go to the visualization settings, to get to the visualization settings, you want to click on this this little bar on the top here. It might say something like conceptual view, it might say something like engineering view. If you click on that bar, there's a little widget here. If you click on that, that brings in your visualization settings toolbar. And if you click on, and you can open the settings just by clicking these little arrows. If you click on wireframe, this turns into a wireframe. And as I mentioned, each cell of this wireframe is a cell on your DEM. So it does not reduce the resolution of your model. It's pure elevation data. So I'm looking at this model right now. It looks good. It looks nice, right? But some of these mountains look kind of blobby, right? I want these models to look realistic. So this is where using a higher resolution DEM comes into play. So let's do that. I'm going to go here. I'm going to remove this feature, remove. And we're going to add in the higher res DEM instead. And so I'm going to go to Raster. And then in my case, it's this Sedona DEM2. So double click on that. Now you notice that in this case, it comes in as a terrain, but does not have a coordinate system associated with it. So in this case, it's good to have your GIS model on hand, because if you have that shape or that raster with you, you can just simply go to properties of that shapefile, go to source, and you can find the coordinate system that is associated with it. In this case, it says unknown. It might be okay. If you go to layers, it should be Arizona Central FIPS feet. So we'll see if it works. To search for a coordinate system, you click on the little button next to the drop-down arrow, and then you can simply search. So let's search for Arizona. And then this is the one that we're going to try right now. It's this Arizona 83 Central, right? Because if you go back to here, it's the Central. There's Arizona East, there's Arizona West, and there's Arizona Central. International foot. So I'm going to click on that. We're going to see if this works. So click on close and refresh. And it did work, so we're good. And as you can see, because I use a higher resolution DEM, there's a lot more detail to this model. As you can see, it's very nice. So these geographic features have a lot more detail to it. You can see there's even the grading for the urban area. So you can see the grading for the roads, the grading for pads for buildings. You can see there's grading for the actual roads on site. So the higher the resolution your DEM, the better the result you're going to get. And the funny thing is, using this image here, you can even find some interesting things on your site, right? So this little hole right here, what is this hole? Well, I noticed this while I was preparing for the tutorial. So like, why is there a hole there? So I looked at the Google map to kind of get a context for what it is. And as it turned out, it's actually the Devil's Kitchen, which is a cool, I guess, geographic tourist area. So people can come here and take a look at what's going on. A sinkhole, yeah. The road's actually called Sinkhole for some reason. So that's just a fun thing you can find out when you're just looking at pure topography, right? Okay, this is great. This is good. Now let's bring in some background imagery. So go back to this drop-down menu here, and let's go back to Raster. This time go into your ortho imagery folder, and then these are all the NAIP imagery that I downloaded from USGS. They come in as JP2 files. With this kind of stuff, you can just bring it in all at the same time. So I'm just going to drag and select all at the same time, then click on open. And then I'm just going to double click on this to configure it. And it automatically knew what coordinate system it is associated with it, so I don't need to touch that. It comes in as a ground imagery, which is good. So this all is good. I don't have to do anything. So just click close and refresh. So in an ideal situation, it would be just as simple as that. Just bring in your data sets. It knows what coordinate system it's associated with it, and you just let it do its thing. So as you can see, bringing in the photography almost makes this thing photorealistic. So this is a lot of fun now, right? So now we can begin to see the geologic features in the site. We can begin to see the airport on the plateau. You can see like this little road that leads up to this plateau. You see you can actually get the grading for that because we used a high res DEM to achieve that. And then all you do now is you have fun with it, right? You can do anything I showed you in the previous video, which is putting buildings in, putting roads in, putting water features in. What I'm going to show you first is how to change the sun and sky settings. So in this little button here that looks kind of like a TV, if you click on that, there is this sun and sky option right here. So if you click on that, this brings up your sun and sky options. And as long as you have high visual quality turned on, you should be able to play with the sun and get some nice shadow studies. So let's make it like an October season and just take a look at these long shadows. And you can see areas where there are actually cool geologic features. It's actually really cool and a lot of fun to play with that. Another thing you can do is in the visualization window here, there is a sun color option here. Right now it has sun color turned on, which I like because it gives a nice warm tone to the light. But if you turn it off, it will just be simple black and white shadows. Maybe that's what you want. And these are just simple black and white shadows. That's just purely your personal preference on how you want your site to be represented. But again, this is basically, and I can with fair amount of confidence say this is the best and most accurate way to model topography for any site in the world, because you're using the highest quality topo information, you're using high quality imagery. The only way that you can top this is to use photogrammetry, which is what Google uses. They use photogrammetry, which is they take a lot of photographs and they use that to generate 3D meshes of the site. This is the only way you can top that, but we don't have the technology to do this kind of stuff. You need drones and that kind of stuff to do this kind of thing. So this is the next best thing. And as students, this is probably as good. All right, so continuing, now what we're going to do is we're going to bring in some shape files. So what we're going to do is we're going to bring in that building footprint data set, right? You see right here. So this is just a plain old building footprint data set. You can download this from any city, county website out there. So let's just bring that in and we're going to make buildings on this site. And actually, this building information does not have building height information, but that's actually okay because in Sedona, everything is like one story, as you can see here. So that just makes my life easy for this tutorial. So what we're going to do is in the drop-down menu, we're going to go to the SHP option, and then we're going to go to the SHP folder, and then go to the building footprints folder, or shapefile. So then brings it in as a vector, so you double click on that. And now it's going to ask for a lot more information than previous data sets. So we first want to go to this type drop-down arrow here, and there's all these options of different ways shapefiles can be read. So roads, trees, streams, etc. If you have a point data set, you can bring that in as trees, so that you can bring in points, the specific points where trees are located as trees, which is kind of cool. You can bring in water feature shapefiles and have that be represented accurately using the water areas. In this case, we're going to use buildings, which is the second from the top. And then it's going to ask for a few things. It's going to ask for a roof height. Since Sedona generally has everything is generally like one story, let's just do something like 18, which is kind of like a story and a half. And then we're going to leave that as is. We're going to add a roof slope as well. Let's maybe give it a 20-degree roof slope or something, maybe 25, whatever. And then here, this is where you start to set like your styles as well. So I don't want to actually adjust this option here. If I click on this pencil here, you can actually pick the building facade that is used for every single building. But if I do that, it will actually make every single building look exactly the same, which is actually not what we want. So for now, I'm just going to click cancel and just leave this as is, just not touch that, because we kind of want to have a more random look. Again, this is for not for designing architecture, it's for designing your backgrounds for your architecture. I'm going to go to the geolocation tab, and this is where I set the coordinate system, and it automatically brings it in as the Arizona 83 Central International Foot shapefile. So this is correct. And then I'm going to click close and refresh, because that should be fine. And if I zoom into the site, you'll begin to see these buildings just populate all along the site. And every single one of them has the same exact height. If you had an attribute for a height field, they would all come in at the correct height as well. But in this case, we don't have that.
With the video you showed us last week,
Yes.
would that essentially be how we get that height information?
Using LiDAR? Yes. So I don't have it for this data set right now, but for instance, and I'll just show this just for as an example. If I go to the building footprint layer in GIS and open the attribute table, anything that's a number, let's say object ID, let's see what kind of number this is. It's just a long integer, can be used as the object that extrudes the feature. Oops. So I think it'll look weird because the range is different, but just for experimentation, if you go into the building footprints, if you go to roof height, I'm going to erase that for now. If you click on this little expression editor next to this thing here, this brings in this dialog within which you can bring in the actual fields from the shapefile. So it actually brings in all the attributes, which is nice. So in this case, I think it was ID, object ID. So object ID, I just double click that and it brings it into the roof height field. Maybe let's divide that by 10. So you can actually add some expression to that as well, because I don't want buildings that are 1,000 feet. But I think we'll still get some 1,000 feet high buildings. Click, oh, okay, this would be weird, but click close and refresh. Let's see what happens. This is a bad idea. This is a bad idea. This is a bad idea. I don't see anything yet. Oh, here. Yeah, this is a bad idea. But you get the point, right? If that number was actually right, you would get.
So if you actually had the building heights in the attribute table, you could bring that in and it would.
Yes. The example that I showed you in the previous video with the St. Louis, that had building height information associated with it, and it brought it into the correct heights. Now this is, honestly, it is weird, but it's actually kind of interesting, you know? This is like an urban, Hong Kong-esque, you know, city within a canyon, you know? This is kind of like a speculative urban campus, you know? A bit too high, but you can see like how using Infraworks can be kind of fun. Anyway, let's not do that. Let's go back here. Let's erase all this stuff. And I'm going to go back to my original thing of 18 and, I don't know, 20. Also, this button right here, roof height above sea level, if you were using LiDAR data sets and you projected that building footprint to a LiDAR data set, that number is going to be the height above sea level. So you want to check that box here, and that will make sure that the building heights come in the correct elevation.
Wait, so why are you not checking it now?
I'm not checking it now because these are not the height above sea level. This is just 18. So what it does is it drapes the shapefile to the topography and then it extrudes it up 18 feet. If you check this box here, it's going to start from the 0 elevation. It's going to figure out the height of the building, and then it's going to project down to touch the topography. That makes sense. Yeah. If you ever run into a situation where you need to figure that out, just let me know. I can troubleshoot for you. So, okay, so we're back to a normal city, and as again, you can go to high visual quality, you can go to the date and time, you can play with the sun. This is probably my favorite thing about this tool, is just playing around with the sun and sky options. I like sun color turned on. All right, so this is all fine and good. And also one thing I might mention is that usually with roads, I actually don't usually bring in the road feature in, because I actually think the roads don't actually help the actual model itself. Really all you need to build a simple base is an aerial photograph, a building footprint, and a DEM image to build photography. And this is enough, in my opinion, to build a simple base for your projects. The next thing we gotta do is, now that you have your base, right? It's all good, it's all set up. Is we wanna bring in our 3D information from our other programs, say like a Rhino program, right? So what I'm gonna do for now is I'm going to go to the visual quality settings and turn off high visual quality. And I'm just going to move the model off screen slightly. If you do this, just move the model off screen, actually speeds up your computer. Having anything in the viewport actually slows down your thing. So if I just do this, this makes the rest of your computer run fast if you're low on processing power. What I did, and in the box folder I should have saved it, is I saved an export from GIS, a CAD file, and I brought that into Rhino. So what we're going to do now is we're going to mess around and see what can we do. How do you bring in your Rhino models into Infraworks? So in order for this to work, you actually need to have an export from GIS to start, because these exports from GIS are geolocated correctly. This is already in the correct location using the correct coordinate system. So whatever you do, your building has to fit within the export of your GIS data set. So let's just do something fun for now. I'm just going to type in building and create some massings in this area. Let's just create a few rectangles. And this is not meant to be fancy. I'm just trying to show you guys how it works. So let's just draw a few massings here and there. And obviously your buildings would have a lot more detail. Not like this. Whatever. So let's say you have a building or something that looks like that. This is oversized, whatever. Let's maybe move it to an area with no buildings. I don't know if this is correct or not, but whatever. So this is kind of where it is, right? When you have your model finished, you select your features. You go to File, Export, Selected, because I have those features selected. I'm just going to save it on my desktop for now. And you want to save it as either one of two formats, either an FBX or an OBJ. FBX or OBJ. These are kind of like the standard model formats that Infraworks accepts well. Infraworks does not accept Rhino models natively, so you actually got to export them separately. So I'm going to choose FBX. FBX is the one I like the most. We're just going to call this one massing. So click OK. So click Save. And then it's going to bring us some FBX export options. I generally leave this as meshes. It has to be a mesh. It can't be a NURBS, which is what Rhino does, is NURBS. So mesh, and I just choose this export materials as FONG, FONG. Then whatever this is, version 7 binary, I just leave this as is. Then it's going to bring in a meshing dialog here. So this is how detailed the mesh will result. I generally like to leave this slider around kind of like the 75% mark. So fewer polygons, more polygons. I find this is a good balance. So I kind of leave around this kind of 75% mark, and then click OK. So back in Infraworks, let's go to Add Data Source and Add 3D Model. Let's add that massing thing we made. It's going to bring it in right here as a 3D model. So we can just configure that. The type, you can bring it as several objects. Let's bring it as a building for now. The other format I would recommend is a road format. That seems weird. There's a reason why I would recommend roads, is because roads are the only feature in Infraworks that you can turn on and off like layers. So actually, let's do that. Let's bring it as a road. I'll show you why in a second. In 3D model, you want to check that box. You see that the model comes in rotated incorrectly. This is because Rhino uses a different axis system than most Autodesk products. This is just Rhino's thing. It's weird. But there's an easy way to fix that. Just check this flip Y and Z thing here, and then this thing automatically is flipped to the correct orientation. So then go back to geolocation. Then you want to set the coordinate system to be the coordinate system of your GIS base, right? So this is the export from GIS. This is the coordinate system that it was exported as. Then click close and refresh. Now the model's going to come in correctly, but as you can see, it came in at the 0 elevation right here. That's because right now this model here is being built on the 0, 0 elevation. So the correct way to do this would be to have contours at the elevation where it was in this Rhino file, and then have this modeled in the correct location. So this is in the correct XY location. It's just in the wrong Z location. So we're just going to move it up vertically using the little gumball thing here. So let's drag it up. And as you can see, it has come in at the correct location within this site. So how do I know it's in the correct location? I just compare it with the buildings around it. There are some of these buildings that look like this around it, and if I go in here, you see that it should match. So this is basically how you bring in Rhino geometry into Infraworks. So if I, for instance, hover my mouse around this area that the building sits at, you see on the bottom left corner of the screen, there is this X, Y, and Z number set here. So this is actual elevation of this model here. So right now it's at like kind of this 4,222 elevation. So if I delete this, I'm just going to remove it. And then go back to Rhino. Let's select this object. Then move it up 4,222. So now this is at the correct elevation, right? If I export that, call it mass. I'll just save over the previous one. Save. Go back to Infraworks. Bring it in again. Using the same exact settings, also use roads, flip the model, set it to this. Now it comes in at the correct location with no adjustments made to it. And then what you do is, as you're designing your project, right? As you're designing your project, you're changing it. Maybe you're increasing the height of it. Maybe you're adding a horribly unstructural cantilever to your project. Maybe you decide to even make that cantilever even worse. Then your studio professor says, just go for it, and then you make it even worse. So this is your studio project. Then you take that and you export it. You save over your previous FBX file and just click OK through the same settings. Then all you need to do in Infraworks is just right-click and refresh that model.
You couldn't do the refresh before you changed the elevation?
Well, I changed the elevation, so I just wanted to bring in fresh. But you could have just done that. And then you just use Infraworks to render the shadows of your site. Now, one other thing I would recommend, Infraworks also is able to remember textures as well. So for instance, if you're a bad architect and you decide to put a texture on some of these things, so let's say you go in here and you go to wood, you go to bamboo, so let's go to rendering mode. Let's add material to that object. Add bamboo to this. You add bamboo to that. Why? Because you're a bad architect and you design like an amateur. You can export that. Export selected. Massing. Okay. And refresh that. And now, voila. Congrats. on your bad architecture. And then your reviewers ask you, well, what's the purpose of this thing? And you say, it's speculative. And then they, oh, okay, fine, so be it. So that's how you bring your information from Rhino into Infraworks. As you can see, it kind of puts in the context really nicely. So again, all you had to do for that to work is just have a GIS base exported from GIS. This is located correctly, so you just locate your model in the correct location and the correct elevation, just export that, and it just comes in the correct location. So I, at my office, never ever model sites ever in Rhino. And it drives me crazy sometimes when my coworkers ask me to export like contours and building footprints and road information into CAD so they can build it in SketchUp. And I'm like, okay, I can do the same exact thing in like 5 minutes and it'll look better. So this has been a game changer as far, ooh, what did I do? I did something. There's also this weird thing here. You can go colorize, you can make it grayscale. You can also make it sepia. These are some of the useless functionality in Infraworks. But yeah, it is what it is. Yes. Okay, so there's a question about interactive placing. So when you're using interactive placing, you actually want your model to be as close as possible to the origin. So let's just take a few of these objects and move it to 0, 0, 0. And let's just make it even worse. Let's copy it over, copy it up, rotate it. And you say to your studio professor, it's speculative. And like, oh, okay. Especially if it's Gia, because she's just like, whatever, it's speculative, I love Gia, so I can make fun of her. Okay, so there's your speculative model right here of your building, right? Maybe you say this should be flip 90 degrees so that you can connect the two things or whatever. Great, awesome. So what you do is you take this, export it, call this massing 2. And then in here, go to 3D model, massing 2, do the same exact process. Let's say bring it in as a road, 3D model, flip the X, Y, and Z, go to geolocation, and it's going to ask for the interactive placing, right? So when you use this tool here, you want to make sure that the XY, you have to set the coordinate system to this XY unit thing here. So there's a bunch of options. There's XY inches, XY feet, XY feet, which is the same thing as XY feet. So you always want to make sure that this unit is the same unit as your Rhino model. And my Rhino model in this case is in feet. If I go to units and check that, it's in feet, as you can see right here. So I'm just going to go in here, set this to whatever it was, click interactive placing, and now you can just basically just pop it in wherever you want. So some of my colleagues who know how to use Infraworks also don't know how to use GIS, right? So there are people who don't know how to use GIS, and so this is what they use when they bring in their buildings. They just use the interactive placing tool to bring in their model information, and that works perfectly fine for them.
When you refresh your model, does it refresh in the same position, or does it relocate again?
Let's find out. So let's just move. Let's make our building even better. Let's rotate this here, and then he was like, "It's a speculative, project." And, oh, okay, that's fine. So export is selected, massing. So it's exported, and let's refresh that. I think it should come in the same location, and it did. So yes, it works. I actually wasn't sure, so that's why I tested it. Oh, look at that. It's even like over the road. So there we go. Also, another fun thing with Infraworks. If any of you guys play video games, especially PC games, you know that to play first-person shooters, you use the WADS keys to move around. That works within Infraworks as well. So you can use the WADS keys to move around. So the WADS keys move you around and rotate, and then the regular arrow keys, they move your, this is like your strafing thing, so you can strafe around your model. That's why I said Infraworks is basically a video game. And actually, I think one time I connected an Xbox controller and it worked with the Xbox controller. But I haven't done that in a while. Okay, then the last thing I want to show you guys, this video has gone quite long, so I don't want to drag it on too long, is why did I use roads when I brought in my geometry. So if you click on this button right here, this in the Data Sources tab, there's this thing called Manage the Order and Visibility of Surface Data. This brings in the layers of your model. So you can see it has the DEM, this is the topography, it has the ortho imagery. It then also has these massings. This is the actual stuff that I brought in as Rhino geometry. And so this is why using roads helps, is so that you can bring in options, right? You can turn off, say, massing 1, click apply, and it'll turn off. You can turn off massing 2, turn back massing 1, apply, that'll turn off this, turn that back on here. This only works for roads. Buildings cannot do that. So that's why bringing in road geometry, bringing in geometry as roads is a good way to do that. The roads is just a label. It doesn't actually change the geometry in a significant way. It just categorizes that geometry as a road, but that just allows you to turn things on and off easily.
You can't do that with buildings.
No, you cannot. It's weird. I don't know why. But again, this kind of goes back to the fact that this tool is a civil engineering tool. This tool was designed for roads, for civil engineers to design roads and highways. So that's why that option only exists there. So with that, I'm going to